All right, Doctor. Do you go, Doctor Alex? I'm not even gonna try your last name. Welcome to Earthly Show and Tell. Why don't you tell me your name and what you do?
Yeah, so my name is Dr. Alexander Mikhalev. I am CEO in one company, which is building privacy-preserving AI assistant, and I'm CTO in industrial AI company called Clarion, and I'm also AI consultant. So I build AI, machine learning, complex systems for a living, and yeah, that's where I come across Earthly, and happy to talk to you.
Awesome. So, what are we looking at here? What problem did Earthly help you solve?
So originally, I found Earthly when I was trying to debug GitHub Actions for Fluvial, which is Infinian streaming platform, and I wanted to make consistent end-to-end tests, which involved spinning up Kafka, including brokers Zookeeper, then spinning up Earthly. Spinning up Infinian Fluvial and then generated data, then doing end-to-end streams. And GitHub Actions for Fluvial, and it's open source project, you can check it, is about 1,000 lines long. You can
That's
imagine
wild.
my joy meditating on it and then waiting for it to come back.
So, so how did you solve this? Did you port it to Earthly, or what was the next step?
So I found Earthly, got pretty excited, and the reason what I really like about Earthly is the ability to switch into interactive mode on failures that allows you to try fixes, but also that consistently I can try debugging in on local machine. I can spin up exactly the same way CI pipeline, and it will work equally well in the cloud. Or I can do my own build, which is on dedicated server, kind of pre-production testing environment. And this is type of consistency I was looking for, and that's where I used Earthly in my any other project for a while. Yes, and I can say I probably tried it in way more ways than you could imagine.
So maybe it would be useful to look at one of your examples. Maybe you could just show um, what you did, why it was helpful.
So let me start from that example, which is probably one of the least standard ones. And the reason for it is I use Earthly to build Firecracker VM. So,
Nice.
as you know, AWS open source Firecracker VM, and it's really lightweight, really fast to start VM, and that's what I thought wouldn't be good instead of using Kubernetes or Docker to create your own private cloud using Bash scripts and Firecracker VMs. So I actually have a deployment where CGI scripts creates Firecracker VM on the back of your login with your GitHub OpenAuth. And the longest part is actually parsing GitHub response. And the whole VM spins under 2 seconds.
That's amazing.
Yeah.
Firecracker comes out of AWS Lambda, right?
Yes,
It's
it's
what
exactly
they use,
AWS Lambda. Right.
and it's written in Rust. And so, yeah, how does this work?
So the way how I use Airflow for it, obviously it's a standard Airflow pipeline, except it needs to have privileges to build rootfs. And what I do here is I create a standard Bionic image, which is not Docker. It's a full virtual machine, except I'm using Docker to create it. And then I fetch the platform code and effectively build a full VM. And this is more complex deployment because it have a UI component. It have a Python fast API, which then embedded in Firecracker VM on the last step, but interim steps involve building VM image, then building VM, checking out the platform code, checking out the fast API code. The platform is like backend cluster, and then checking out the UI, then pulling it all together. Yeah, and it's all done earthly, and it's all works very nice. Uh, include
What's the format of a Firecracker VM? Like what's the thing you're producing?
So Firecracker VM consists of two things. One of them is a kernel. I'm using Earthly to build Linux kernel. Uh,
Oh wow.
but also then I'm using Airflow to turn Docker, which is built at the last stage of the rootfs, and create a rootfs petition out of the Docker container. And it's all fully bootable. And as I said, whole VM fires up under well, it's literally fires under 1 second. Uh,
That's amazing. So you use Docker to create the file system that you start in Firecracker?
yes, correct.
Yeah, that's clever.
Yeah.
That's
So, and you
that's
can see it's literally mounting the loop device and then export container, and then runs Docker copy to archive into like loopback device, and that's what creates the full rootfs. But before that, we have to make sure that system services are correct, and the SSH keys and artifacts and anything else is there.
and so the kernel runs inside the Firecracker?
Yeah. So in order to spin Firecracker VM, you need two of those things. One is the kernel, and another is rootfs. So, and there is a config file which looks roughly like that. So that's kernel image path, which is built using Fly, and that's rootfs path, which is again built using Fly. So what it says is effectively it spins the machine, which is single CPU and 512 megabytes of RAM.
Because correct me if I'm wrong, when you run a Docker container, it is a shared kernel virtualization. You're using the kernel of the machine it runs on. But when you do Firecracker, I guess it has its own kernel. It's
Yeah,
not shared
it's
kernel.
not Docker kernel, and the only use for Docker here is to build leverage Docker enabled tooling to build Firecracker VM, and what allows millisecond startup time, because yes, it's using KVM. It's not using Docker kernel, using its own kernel, and that's why. But in the reason why people don't do it that way, because it's actually quite complex. So you saw there are a number of steps which we need to do, like um, creating literally building new Linux kernel, because it should match to our rootfs, and then setting network settings. And but the way how I'm using Docker here is roughly similar to Docker is just packaged tar files. So I'm literally copying, building everything using Docker, but then create a Docker snapshot and turn it into rootfs. And
That's cool.
one of so the benefit of Earthly is try to do it in any other tool, and you'll find it's quite cumbersome. Including Firecracker's own build tooling is actually uh, more difficult than this little script.
That's awesome.
Right.
So what would you say, if somebody's curious in Earthly, but maybe they're not building their own kernel and starting like I don't know. What do you
So
sell Earthly for me?
it's actually quite easy. So, and as I said, I try to use Earthly rather consistently because it gives me a consistent experience. So this is the more standard approach. So I have a Python-based fast API backend, and I have a Svelte-based front end. So what I'm doing is building fast API, creating virtual environments for Python, and then for release, I'm copying the front-end assets into, again, a single Docker deployment image, which then I push into GitHub repository. And that's way more traditional thing, except as you can see, instead of using two Dockers, I embed front-end output into Docker image. So I only need single image to start both front-end and back-end, and it's all single binary, really easy to move around. And that little thing is actually quite important because that allows me to save front-end assets and make sure that I rebuild them consistently using Node.js and the rest of the dependencies. And so this is, again, nice and simple.
Mhm.
Atomic server from the friend who is now using Airflow too. And I did manage to sell him early, so your question is quite relevant. And he have a Rust-based application, which also have a
Mhm.
front-end components, which are React-based components. And as you can see, he does everything here in Airflow. So the pipeline builds browser and tests, lints it, formats it, creates packages, and it does it for both front end and back end, and then runs end-to-end testing. One of the additional complications here is that it's cross-platform built, so it runs for at least 3 systems, as you can see on my screen. And it
Mhm.
also have a muscle Docker build, which allows Docker pool working on different architectures. And yeah, I think that works really well and it works brilliantly. And one of the things which was differentiator for Airflow, where you can upload builds directly from your local machine to satellites, but interactive prompt when the build fails still goes onto your local machine. I'm not sure if it still works the same way. I haven't but yeah, I think one of the major differentiators was you can run builds remotely, which means you can cache quite a lot of preconditions and prefetching.
Mhm.
Because, so for example, this one is checking out the source, but then before we actually do install, we do fetch. And that's where I think there is a lot of there are a lot of opportunities to prefetch all artifacts, cache them locally, and then rebuild many times for different tests or releases.
Yeah, there's a lot of repeat work that happens in builds, right? So when you can cache them, it's
Yeah,
really
and I think one of the ways I intend to explore Airflow going forward is to have a local registry for crates and numbers, for example, using Gitea. And what I want to be able to do is to cache them not only using Airflow, but also using Gitea. That means I don't need to think about delays going to GitHub registry or GitHub or Docker Hub rates, while my packages are still not in the conditions where they can be published onto crates.io. And another thing which I'm currently exploring, for example, this machine have a Panamax proxy, which is a mirror of crates.io for Rust. So
oh.
it takes like 40 gigabyte local storage, but my rebuild of the Rust applications are way faster, and they are like really noticeably faster. And these are two directions I want to explore carefully. But as I said, uh, I think I managed to do pretty much anything I wanted differently, other than being able to build for Apple Macs and being able to build for mm, like Windows and or mobile services.
Yeah.
Yeah, I think other than that, the pipelines are now solid. I want to show one more thing, which I didn't quite plan to show. So this little Airflow file, it's actually very small. What it does, it's on a commit or in a particular repository, which is actually textual repository. It have no code in it. It grabs
Hmm.
the that's actually not that, but this one just builds the Rust application. Again, it's quite straightforward. You saw that simple logsec parser. So effectively, what it does, logsec is not taking tool. It stores data in Markdown. When you commit into this repository and it uses Git, it actually grabs or rebuilds the simple Rust program and then runs it and then produces output, which is like knowledge graph, rebuilt knowledge graph. But the interesting bit I wanted to highlight is this login operator. This is where I'm using one password connect. uh, so that line says no cache, and it using one password connect host and token to run AWS S3 sync and synchronize data with S3 bucket. The reason why I'm so curious to highlight it is um, Airflow project, this particular Airflow project, have no access to AWS secrets. The only thing which Airflow project have access to is one password connect string, which is a host and a token. So on that line, Airflow build process logs into one password connect server and then grabs corresponding AWS settings, and that what allows to run AWS S3 sync. And I think that can be reused to reiterate on making sure the secrets are consistent across different environments without need to specify them. But also it means that this line will work exactly the same way on dev, staging, and production, except in production, it obviously will go into different world than in staging or pre-production environment. And yeah, so I think on that one, we'll probably I run out of breath.
Well, that's very cool to see all these examples. Uh, I know you're super excited about Earthly, and I think that that's great to see. But I also know that you do 1,000 things at once. So thank you so much for your time. Um, yeah,
Any more questions or any deep dives required?
I mean, I think we covered some interesting things, right? I think that's a great walkthrough of some of the projects you're doing. Is there anything else you'd like to add, or?
I think we can leverage more of the locality of the cache, and I think that's making it reusable. Probably is one of the big topics. Um, I think Earthly supports Docker in the Docker, and I think I'm not sure if it's highlighted, but the Firecracker job spins the Docker, and then inside of this Docker, it runs Docker CP, which spins up another Docker container, and so that kind of you make a tree of Dockers. Some of the aspects, when other teams, for example, Atomic Server uses cross build, which is quite fashionable Rust cross-compiling
Mhm.
tools. I think it would be very easy, way easier to be redone using Earthly alone, and I probably will have a crack on it during next month, let's say, because when we run cross build, it also spins Docker and it spins cargo build inside that Docker. So the Earthly have less chances of reusing build cache. And I think we can very easily rebuild it because you saw me using platform tags. I noticed the satellite supports about 6 or 7 platforms.
Mhm.
So I may have a go on building for Terraform AI. I may build a MIPS binary just for the fun of it. Unfortunately, OpenSSL normally doesn't work there, so I might be stuck
Yeah,
with.
the cross build is super interesting. I looked at it once too. So it will run in emulation mode these various Docker images, and that's why it can be slow because of the emulation. It would be great in the future if we could kind of fan out to different satellites,
Mhm.
right? That actually had the architecture and run it non-emulated. Yeah, the future
Well,
is exciting.
yeah, absolutely,
Yeah.
great. And,
All right. Well, thanks for your time.
yeah, so did I help you, Adam?
Yeah, you definitely helped.